Let's learn 3 sorting algorithms in C in this video. The first sort algorithm will be the bubble sort. This is the most simplest of the kind, and here there are repeated comparisons which are made between adjacent elements, and if they are not in the right order, the elements are swapped. So this process continues as long as the array is sorted. Let's understand the logic behind the bubble sort algorithm before we go for the code implementation. Assume this is the original array. There are 6 elements in the array, and the subscripts are shown above 0 to 5. In general, for n elements, bubble sort will go through n minus 1 passes. So every pass, the comparison starts from the 0th subscript. So the first pass, starting from the 0th subscript, every 2 adjacent element is checked. Now assume we are doing this for the ascending order. If the 2 elements in comparison are in the right order, no swapping happens, and the comparison happens with the next 2 elements, next 2 adjacent elements. That will be 43 and a 6. Now they are not in the right order, so they will be swapped. So 6 will come here, and 43 goes in the place of 6. Now the next comparison will be between 43 and 13. They are not in the right order, so 13 is brought here and 43 goes to that place. The next comparison is between 43 and 19. They are not in the right order, so 93 and 43 are swapped. And finally 43 and 2 are compared. They are not in the right order, so 2 and 43 are compared. So at the end of the first pass, the heaviest element will go to the end of the iteration. This will be end of pass 1. In the second pass, the comparison again starts from the 0th subscript. So 12 and 6 are being compared. Now they are not in the right order, so these 2 elements are going to be swapped. Now the comparison is between 12 and 13. They are in the right order, so no swapping happens. The next comparison is between 13 and 19. They are in the right order, so no swapping happens. And then the comparison is between 19 and 2. Now they are not in the right order, so swapping happens. So 2 comes here and 19 goes to its place. Now this element is already sorted in the previous iteration. That will not be included in the subsequent passes, making the sorting efficient. So this will be the status at the end of the second pass. In the third pass, 6 and 12 are compared. Again the comparison starting from the 0th subscript. They are in the right order, so no change there. 12 and 13 are compared. They are in the right order, no swapping. 13 and 2 are compared. We need a swapping there. So 2 comes here, and then 13 goes in its place. And that will be the end of the third pass. The fourth pass will start with whatever the last status was for the pass 3. So in the fourth pass, again starting from 0th subscript, 6 and 12 are compared. They are in the right order, so no swapping there. 12 and 2 are compared. They are not in the right order, so 12 and 2 are swapped. So 2 comes here and 12 goes there. And with that, the rest of the elements are not compared because they are already in the right position. So this will be the status at the end of the fourth pass. And in the fifth pass, again starting from the subscript 0, the adjacent elements are compared. 6 and 2 are not in the right order, so they will be swapped. So 2 comes here and 6 goes there. And end of the fifth pass, you will find the array to be sorted. So this is the algorithm logic behind the bubble sort algorithm. Every time starting from the 0th subscript, every 2 adjacent element is compared, and if they are not in the right order, they are swapped. So now let's look at the code implementation for the bubble sort algorithm. I have my array statically initialized. Now the outer loop will happen for k starting with a 0, and for each element of the array, so until k less than a 6, incrementing k every time. And within this there is a inner loop which will happen. Again it has to start with a 0 because every comparison starts from the 0th subscript, and as long as j is less than the number of elements, so here it happens to be 6, so probably we can have a n that is initialized to the size of the array, and the j has to traverse until it's less than n minus k minus 1. So this expression will ensure that the elements that were arranged at the end of every pass towards the end of the array will not be included in the subsequent comparisons, and every time j is incremented. So what's to happen within the inner loop? Now this is ascending order, so any jth element in the array, if it is more than or equal to the j plus 1th element in the array, now those two elements are to be swapped. Now in case of a swapping, there are different ways of swapping in C code. We could either have a temporary variable which takes the jth element, and the jth element is going to be overwritten with the j plus 1th element, and the j plus 1th element is going to be overwritten with the value that's stored in temp. So the end of these statements, the j and the j plus 1th element will be swapped. So when this loop is fully completed, when you come out of the outermost for, if I try to print the array's contents, you will notice the array elements are in the ascending order. So within the loop we'll have each element printed with a format specifier and a space between each element. We'll have every a of k shown. So let's execute the code. So the array contents are now shown in ascending order. If we want the ordering in descending order, everything else about the code will be the same. Only this relational operator you have to change it to a less than. So if the jth element is less than the j, that is the adjacent element, then we need to swap. So when I run the code, you will get the array contents to be arranged in descending order. The next algorithm is the exchange selection sort. In this algorithm, every element that is traversed in the array is compared with the rest of the array to find the smallest element, and that smallest element is exchanged appropriately so that it's placed in the correct sorted position. Let's understand the logic behind the selection sort. The array elements are shown, the subscripts are shown there. A variable small is to hold initially whatever the outer loop, that is referred to by k, let's assume. The kth element is stored in small and its corresponding subscript is stored in pos. Now there will be a j which starts from the very k, and it will search the rest of the array with the element in small. So 43 and 12, 6 and 12. Now 6 is smaller than 12, so my small will be updated to store that 6 which is found in subscript 2. So pos will change to that subscript. And now 13 and 6, 19 and 6, 2 and 6. So 2 is smaller than 6, so the small is updated to 2, and pos is updated to store the index where the 2 was found, which is a 5. With this, the first iteration is over. So when you come out of the inner loop, the outer loop, you are going to swap the element in the kth position and element in position pos. Element in position pos, that is pos was a 5, element in position pos was a 2. So 2 and 12 will be swapped. So 2 goes there and 12 comes here. Now this will be end of pass 1. When this pass 2 starts, k will start from this subscript and j will take all values. Before that, the small will be assigned to that value what my k refers to, along with the appropriate subscript, and with that I'll be comparing the rest of the array elements with the small. So 6 and 43, 6 is smaller, so my small is updated to a 6, and pos should take the subscript what my 6 is stored, where my 6 is stored, that will be subscript 2. And next a 13 and a 6, 19 and a 6, 12 and a 6, there will be no changes because 6 will be the smallest. And now at the end of this iteration, element in the kth position and the element in position 2 should be swapped. So 6 would come here and 43 would go here. Now the next iteration, my k would have started from here, my small would have started with a 43 in position 2, and that I'll compare with the remaining array elements. 43 and 13, 13 is smaller, so small will be updated to 13 and the position will be changed to a 3 because 13 is found in subscript 3. 19 and 13, there won't be a change. 12 and 13, so 12 is smaller, So I'll have my 12 updated to small, and the subscript where 12 was found, that will be a 5. Now at the end of that iteration, element in the kth position and element in position pos should be swapped. That is 43 and 12 should be swapped. So 12 will come here and 43 will go to where 12 was. The next iteration, the k will start from subscript 3 and small will store the element that is in subscript 3, that is at 13. Pos will be that subscript 3, and then I'll compare the remaining elements. So remaining elements, if you notice, between 19 and 13, 43 and 13, there won't be any change needed because 19 is in the 13 is in the proper place. The next iteration continues with k taking a 4 and small will take a value 19. The subscript will be a 4, and again that, if you notice, the rest of the array element, that will be a 43. When that's compared, 19 is in the proper place, so there won't be a swap needed. So with that, the n-1 passes will be over and your array will now be in the required order. Now for the code implementation. So like before, I have the array statically initialized. Now the outer loop will start from k is a 0 until k is less than n-1 and increment a k. Now within the outer loop, we'll have this small to take what is in position element in a of k, and the pos will be the kth subscript itself. With this, I shall start my inner loop, kth element itself, and will traverse until the entire array is compared, and every time within this loop I have to check if any jth element is smaller than what is supposed to be small. So if I find any jth element that is smaller than what is supposed to be small, I shall update my small to be that jth element and note down the position as the subscript j. So this loop, once it's over, the variable small will have the smallest element and pos will have the subscript where the smallest element was found. Now coming out of the inner loop, what did we do in the while understanding the logic? We swapped the element in the kth position and the element in the position pos. So I could have the swapping done using a temporary variable where temp will hold the element in the kth position, and in the kth position I will overwrite with whatever was there in small, and in position pos goes this element that was stored in temp. So once the loop is fully done, we'll come out and display the array to be in ascending order. So the array elements are now shown in ascending order. Now if the same thing was to be done with descending order, now a few changes needed. So for the literal sense, we can have this variable changed to a big. So the big shall be what is in the kth position. So with everything else is going to be the same, I have to compare every kth value with the rest of the array to see which element is bigger than what is supposed to be big. So any jth element, if it is more than what is supposed to be big, I'll note down or I'll update my big to be that a of j, and I'll note down the pos as the jth subscript. So like before, coming out of the inner loop, I have to be swapping the element in the kth position and the element in position pos so that the array is arranged. So when I run the code, my array contents are now in descending order. The next sort is the insertion sort, and here we assume that the first element is actually arranged in a sorted form. So we'll literally be starting only from subscript 1, that is the second element. And in selection sort, we started every time, the outer loop we started for every kth element and compared towards the right all the elements in the array. In insertion sort, we'll start from a particular kth element and compare all the elements to the left, the beginning of the array, and then arrange them in the appropriate position. So let's understand the logic behind insertion sort. Now this black arrow we'll assume as the one that iterates through the outer loop, and this will be for the inner loop. So my outer loop starts with subscript 1, and inner loop will start from the initial subscript, that is 1 less than the outer loop subscript. So when k is starting with the k is a subscript of the outer loop, you assume k is starting with the 1, j will start from k minus 1, and it will traverse in the left direction. Every time I'll compare this kth element, which I can store in a temporary variable. So temp is storing what my k is referring to, that is a 43, and then I'll compare the elements in the positions prior to k. Now if I find any value, that is if I find my temp to be lesser than any value that the inner loop is referring to, then I shall overwrite. So I'll explain that in the next pass, because just now 12 is anyway lesser than 43, so there's no swap that's going to happen. Now the outer loop will continue with the next subscript, so temp will store the element that is there in that subscript, which is a 6. Now j will start from every time one value prior to k. So temp and the jth element are compared. Now since temp is lesser, now this is j, so this will refer to j plus 1th position. So the j plus 1th position, the element in that will be overwritten with what is in the jth position. So the 6 will be literally overwritten by a 43, and then the j is going to be decremented further. Now again temp and the jth element are compared. Temp is lesser, so what is in the jth position will be overwriting what is there in the j plus 1th position. So if this is j, this element is j plus 1. So the jth element will overwrite what is in the j plus 1th position. So 43 is going to be overwritten with a 12, and with that j is going to be further decremented. It's already a 0 at that point, so when I further decrement, what will it have? A minus 1. So the looping condition is as long as the temp is less than every jth element, or j has become as long as j is greater than or equal to 0. So once j becomes less than 0, now there will be an expression that we will write in the j plus 1th position. I will put what is in temp. So j is just now what? A minus 1. What is j plus 1? Minus 1 plus 1, that is a 0. In the 0th position we will put this 6. So with that, pass 1 is the current pass is over. The next iteration, the outer loop continues with subscript 3, and temp will store whatever is there in subscript 3, so that is a 13, and j will start from the value just before k. So k is a 3, j will start with subscript 2, and now the temp and a of j, the jth element, are compared. Temp is lesser, so what did I say in that case? The element in the jth position should override the element in the j plus 1th position. So 13 is going to be overwritten with a 43, and then j is decremented to point to the next location. Now temp and the jth element are compared. If temp is lesser, then we should have done what I told just now, but temp is more. Temp is more than or greater than what is in the jth element. What expression are we supposed to follow? In the j plus 1th position, put back what is in temp. So if this is j, this will be j plus 1th position. So temp will be written into the value that is in temp will be written in the j plus 1th position. Now the outer loop continues with subscript 4. Temp will store what is in that subscript, that is a 19. J will start from the k minus 1th position, and now temp and the jth element are compared. Temp is less than the jth element, so in j plus 1 I have to put what is in j. So this is j, this will be j plus 1. So in j plus 1 I will overwrite what is in j, and my j will decrement further. Now the temp is greater than what is in the jth position. So what is the expression to be followed? In A of j plus 1, put what is in temp. So my temp will be written into the j plus 1th place. And in the last iteration, the subscript to be traversed will be a 5, and temp will store what is in that subscript, that's a 2. And j will start from one position prior to the kth subscript. Again the whole loop continues. Again let me repeat, the loop continues as long as the temp is less than any jth element, or j has become, as long as j is greater than or equal to 0. So once j becomes less than 0, we have to stop the loop, inner loop. So let's compare again. Temp is a 2, 2 and 43 are compared. So the expression to be followed is what is in the jth position has to override j plus 1th position. So 43 will overwrite a 2 and j will decrement to the previous location. Temp is lesser than the jth element, so what is in j will override the j plus 1th position. So 19 will overwrite that 43 and j is decremented. Temp is lesser than the jth element, so the jth element should override the j plus 1th element. So 19 is overwritten with a 13, j is decremented. Temp is lesser than the jth element, therefore what is in j has to override the j plus 1th position. So 12 will overwrite a 13 and j is decremented. Temp is lesser than the jth element, so what is in j has to override the jth position. So 12 will be overwritten with a 6 and then j is decremented. So this is the other condition. Which condition? J has become lesser than 0. In that case, what is the expression to be followed? In the j plus 1th position, you write what is in temp. So if this is minus 1, that is a j plus 1 will be a 0. In that position, I'll put what is in temp. So that will leave your array sorted. So now let's look at the code implementation for insertion sort. I have this array statically initialized. I declared the other required variables. Now the outer loop, I told you, has to start from subscript 1 and it will traverse until the rest of the array. And within the outer loop, what am I to do first? Initially, every kth element has to be stored in the variable temp, because it's this temp that I'm going to compare with all the elements in the left direction until the beginning of the array. So my inner loop will start every time j will start from one subscript previous to what my k is referring to, and the condition that is to be checked is multiple conditions that I said, as long as temp is less than or equal to every jth element, as well as long as j is greater than or equal to a 0. And the updation of j has to be minus minus, because we are comparing elements from the current position until the beginning of the array. And if both the conditions are true, what am I to do? Every j plus 1th element has to be overwritten with the element in the jth position. Now when will I leave the inner loop and come out? Either what is in temp is more than what is in the jth position, or j has reached a minus 1. In that case, the expression will be in the j plus 1th position, I should put what is in temp. And with that, when I come out of my loop, I execute, I run the loop to print. It should show the array in the required order, ascending order. Now if this was needed for descending order, a few changes only. So for descending order, I must have had here at this point. So only change that I'll be including there will be as long as temp is more than or equal to the jth element. Everything else will continue to be the same. So when I run the code, I'll get the status in the descending order. This is a table showing a comparison of all the three sort algorithms we just saw, based on the number of swaps, the time complexity, a real life example for each, and so on. Take time and have a look at all the points listed out. But the bottom line is insertion sort will be the most efficient and the best amongst the three, particularly when your array or the data set is small and it is nearly sorted, because it will require only fewer comparisons. Now we will see the 2D numeric arrays in the coming video. Do subscribe for more videos and see.